Assalamu alaikum, everyone, and good afternoon, and welcome to our informative webinar on housing tech innovations. We are thrilled to have every one of you with us and the groundbreaking solution shaping the future of housing in Pakistan and beyond. So, I am Durre Shahwar, will be host of this webinar, joined by my co-host Asim Suleri Saab, who is the senior infrastructure engineer from Punjab Affordable Housing Program. Together, we are going to take you through this webinar, our tech forward journey, where our domains will be Think Smart Homes, Sustainable Solution, and 3D printed walls, and a lot more. So let's moving forward. I'll give floor to Asim Suleri Saab.
Good afternoon, everyone, and a very warm welcome to this webinar. I'm an infrastructure engineer at Punjab Affordable Housing Program. Before we start this webinar, I will quickly introduce you to the development objective of the Punjab Affordable Housing Program. This program was developed to support the government of Punjab in strengthening its housing institutions and systems and enhancing the quality and quantity of affordable housing supply. To achieve this goal, World Bank has allocated $200 million, and the counterpart Punjab government will contribute $50 million. In this program, we are required to construct 37,000 housing units in Punjab before the closure of fiscal year 2027. And half of the housing units are required to be designed on green design principles. So 37,000 housing units in just 2 years' time, approximately. It's a very hard target, but not impossible. We need to find alternative housing solutions with minimum carbon footprint. As you know, there are various techniques used in the construction of houses. Traditionally, we construct buildings with load-bearing walls and concrete structures, with reinforced concrete structures. And as an alternative, we have prefabricated buildings, which may be modeled or manufactured off-site. Today, we will also explore another revolutionary technique of building homes with 3D printing. It's a new technology not yet introduced in Pakistan, but in the rest of the world, people are working on 3D printing. Now, I would like to hand over the floor to Dr. Adeel Ghayur, who will walk us through his groundbreaking work in 3D printing with sustainable recyclable materials and how Lignik could reshape the future of the housing. It's an invention of Dr. Adeel. Ma'am, please, introduction of.
So thank you so much, Asim Saab, for initial introduction. Okay, so moving ahead, we are having 3 speakers with us. First of all, there are this session or this webinar will be divided into 3 sections, 3 parts. First part will be headed by Dr. Adeel Ghayur. Then second part will be by Dr. Nabeel Siddiqui, and the third part will be Ms. Marisa Batool. So let me start the introduction. Dr. Adeel Ghayur, first speaker needs no introduction, a pioneer in biosynthetic engineering and the mind behind Lignik. Please welcome Dr. Adeel Ghayur.
Thank you. Can you hear me?
Yes, sir. You are audible.
Okay. Let me share my slides and let me know if you are able to see it. Just give me a sec. Are you able to see the slides?
Yes, sir. They are on the screens, and you are given 20 minutes and 10 minutes will be for the question answers. Go ahead, sir.
All right. So let me start by thanking the Punjab Affordable Housing Program and the program director for the talk on an area that is very near to my heart, that is Lignik, and then 3D printing and high-tech housing. I'll begin by briefly addressing the challenges facing the construction industry and the technological solutions currently available. From there, I will introduce Lignik, a groundbreaking material that stands out as the world's first in many aspects. I will highlight its achievements, the strengths and applications of a Lignik house, as well as its potential for generating employment and fostering industrial growth. I will also touch on integrating Lignik into the broader framework of Hexacity, as well as the next steps before concluding. Today's construction and building industry in Pakistan and across the globe faces significant challenges. We are all too familiar with the ever increasing costs juxtaposed against stringent budgets for home ownership. The shortage of skilled labor further exacerbates prolonged timelines. Added to this are the high emissions associated with construction. In fact, the housing and building industry accounts for 38% of global greenhouse gas emissions, consumes half of all globally mined materials, generates 34% of global waste, and yet remains unable to provide housing for 1.5 billion people worldwide. In Pakistan, the situation is similar, with an estimated shortage of over 10 million housing units. The prevalent method of double brick concrete construction in the country is associated with a significant environmental impact, with emissions reaching 40 tons for every 100 meters square of construction. Specifically, bricks contribute 0.5 tons of emissions per ton, cement adds 1 ton per ton, and steel accounts for 2 tons per ton. However, it's not all doom and gloom. Technological solutions, particularly prefab construction and advanced materials, offer promising avenues for addressing these challenges. Lignik is an innovative technology that originated in Pakistan following the completion of my Green Bricks project. The aim of that project was to tackle the multifaceted challenges facing the construction industry along with the related social issues. However, I concluded that simply making bricks environmentally friendly would not suffice to resolve these complex problems. Given the technological limitations in Pakistan at the time, I chose to further develop the concept in Australia. Looking back, it's remarkable to think that the concept of 3D printed composite house in construction was relatively unfamiliar even in Australia at that time. I faced challenges explaining the concept of Lignik even to academics. The vision for Lignik was groundbreaking: to develop the world's first material made from carbon dioxide, which would be 100% recyclable and 3D printable. The ultimate goal was to print a house in just 1 day at a cost lower than that of traditional housing. This diagram on the slide illustrates the overall biosynthetic process where wastes and carbon dioxide are supplied to microbes. These microbes convert them into a chemical, which is subsequently polymerized into lignin. Since lignin is derived from carbon dioxide, it surpasses net zero emissions and is classified as a negative emission technology, as it actively removes carbon dioxide from the atmosphere. This material can be used not only for housing but for a wide range of applications such as furniture and more. Currently, Lignik holds the distinction of being the world's first engineering biopolymer derived from carbon dioxide. This is a microscopic image showcasing the microbes consuming carbon dioxide and waste. It captures the microbes in action, actively processing these inputs and producing their output. Here we have Lignik composite samples showcasing 3 variations, each with distinct properties. Our testing focused on fine-tuning the composite's characteristics to explore its potential applications. As with any polymer composite, its properties can be adjusted to meet specific requirements. Here are additional samples with further variations. Being a polymer, Lignik offers the flexibility to be molded into virtually any shape or design, catering to diverse needs and applications. Lignik has garnered notable accomplishments, including recognized by the Asian Development Bank as a game-changer technology for the construction industry. It earned the performance bonus in CSIRO's ON program, among other achievements. Lignik is versatile, suitable for both 2D and 3D prefab construction. As it is derived from carbon dioxide, constructing a 100-meter square house with lignin removes 10 tons of carbon dioxide from the atmosphere while also offsetting an additional 40 tons. This remarkable scale of carbon dioxide sequestration holds immense potential for combating climate change, with the capacity to offset between 500 million and 1 billion tons in Pakistan alone. In terms of architecture, Lignik offers remarkable design flexibility. Whether traditional or modern, any concept can be brought to life using this innovative material. Lignik offers several significant advantages compared to competing materials. It is potentially lower in cost and 100% renewable. Furthermore, a house built with lignin can be designed to be disaster resistant, such as in case of earthquakes. However, this would require incorporating structural engineering considerations for disaster-prone areas into the building design. Another key benefit of using Lignik is the possibility of integrating mechanical, electrical, and plumbing assemblies directly during the 3D printing process. This is not only helping to reduce construction costs, but also speed up the building timeline. Thanks to these strengths, Lignik houses have a wide range of applications. They are ideal for defense purposes where rapid deployment and withdrawal is essential. They are also well suited for government buildings, hostels, schools, clinics, and most importantly, sustainable urban housing. Additionally, Lignik houses are perfect for situations requiring fast post-disaster deployment solutions. Other applications include hotels, restaurant buildings, and infrastructure for remote villages, towns, and off-grid sites. In addition to its numerous applications and strengths, Lignik buildings have the potential to significantly boost industry and employment in the region. By fostering the growth of associated industries, lignin production and housing can act as a catalyst for regional development. In areas where lignin is produced and utilized, it is expected to drive growth in the renewable energy sector, agriculture industry, waste management, and advanced manufacturing. Additionally, it will stimulate the real estate market, furniture production, chemical and fertilizer industries, and most notably, biomanufacturing and agricultural technology. This multifaceted impact positions Lignik as a transformative force for economic and industrial development in a region. Hexacity represents a sustainable urban development vision built upon the principles of our cycle economy. The concept focuses on integrating sustainable housing into the framework of overall regional development. By adhering to the earth cycle economy, Hexacity aims to maximize sustainability, promote recycling, generate employment, and boost industry and economic activity within small, localized regions. This is achieved through distributed manufacturing and recycling, fostering self-sufficient regional economies where locally consumed products are both produced and recycled within the community. Hexacity's layout seamlessly blends urban and agricultural spaces to establish a vibrant and sustainable environment. Its hexagonal layout organizes the city into specialized vertices, while the interspersed cultivated lands provide sufficient space for crop farming, enhancing resource allocation and sustainability. Three of the six corners house suburbs, providing residential areas. The fourth vertex is dedicated to a transportation hub, fostering connectivity and supporting economic growth. The fifth corner hosts a university, serving as a center for education and innovation. The sixth corner is designated as an industrial area, featuring factories specializing in recycling and green manufacturing. At its core lies a biorefinery serving as the anchor industry for this industrial hub. At the center of Hexas City is the commercial hub, intentionally designed to reduce residential space while maximizing commercial zones. This strategic arrangement ensures residents have convenient access to essential services and ample employment opportunities. For the application of Lignik and similar materials in Pakistan's urban development, the first step is techno-economic simulations to evaluate the technical and economic aspects. In parallel, it will be important to cultivate robust indigenous research and development capabilities. This process will take time, but it is necessary to facilitate the upskilling of the workforce as these technologies transition to commercial viability in the near future. The second step involves producing panels for the construction of a pilot house. To expedite this phase, the approach would focus on 2D prefabrication rather than 3D. The pilot house will serve as a proof of concept, enabling thorough testing for larger scale 3D implementation. Upon achieving satisfactory results, the project can progress to constructing a 3D printed model village, potentially encompassing housing, a clinic, and a school. Here we have two houses that mark significant milestones in the world of construction innovation. The house on the left holds the distinction of being the world's first 3D printed composite house. Built using engineering polymers similar to lignin, though derived from petrochemicals. This house was constructed in Ukraine in 2017. However, the company behind it ceased operations following the onset of the Ukraine war. On the right is the world's first 3D printed house made from biopolymers developed by the University of Maine in 2022. Unlike lignin, this innovation uses wood as the raw material rather than crop waste or other bio-wastes. Given the United States' extensive forest industry, accessing trees for the purpose of construction is relatively straightforward. As we have seen today, Lignik is not just a groundbreaking material with numerous world-first achievements to its name. No country has yet claimed the distinction of building the world's first house using a biosynthetic material derived from carbon dioxide and waste. Pakistan has the unique opportunity to seize this moment and make history as the first country to achieve this milestone. After all, there can only be one first, and Pakistan has the potential to claim it. Lignin holds immense promise for removing carbon dioxide from the atmosphere, not only mitigating climate change, but actively helping to reverse it. Additionally, it has the potential to drive significant employment generation and industrial activity in the region while providing affordable and rapid housing solutions. The value proposition can be further enhanced by integrating these prefabrication technologies into the broader concept of hexacity. The next step includes conducting techno-economic simulations, fostering university collaborations, and constructing the pilot house, the world's first of its kind. Let us come together and stamp our names on this house. Thank you.
That was fantastic. Dr. Adeel, thank you so much for shedding light on the innovative applications of lignin in biosynthetic engineering and its potential impact on the housing industry. Thank you so very much. Okay, so meanwhile, we'll move towards the question answers. For this topic, if anyone from the audience has any question, they can raise their hands. And I have another idea. Let's take a selfie. So everyone, please turn on your cameras. So we take a selfie by waving your hands. Okay. I'm just waiting. So everybody, please raise your hands. So it's a selfie time from Punjab Affordable Housing. Thank you, everybody, for cooperating. Okay, so let me take the selfie. Okay, so as we are having more people on camera, 1, 2, 3. Thank you so very much. Okay, so moving ahead towards the questions. So any questions?
Yeah, can I ask a question, Dr.
Sure, sure. Yes,
Yeah.
Abdul, yes, go ahead.
Yeah, my name is Dr. Sultan Nizami. I'm a professor in Sustainable Development Study Center, Government College, University, Lahore. I'm a scientific lead in another project funded by World Bank. It's called PLEASE, and we are trying to convert the plastics into a construction materials like walkways, like bricks. We are trying to encapsulate the plastics polymers, and then we have a cemented. So I can also share later on, I would be networking with the key a stakeholder of this Punjab affordable housing programs as well with my research team. Obviously, my research team is more working on modeling and simulation along with the experimental point of view. I have a quick question with Dr. Adeel. It's fantastic, excellent. And I hope the idea come through practically in Pakistan. Have you conducted the life cycle costing, life cycle environmental impacts? Have seen the social impact, environmental impacts about these linking what you are the 3D printing houses?
That's a good question. So we have done the costing for Australia. We have done the testing as well. That's why we know that it's 100% recyclable. So when we feed it back to the microbes are able to consume it and reproduce the chemical. So this is a very unique thing.
Have the pilot house in Australia?
No, as I mentioned in my presentation, there is no pilot house at the moment.
So, for example, like in Pakistani context and scenario, if we have to build the pilot, so in how much time it will be possible to have this pilot small house?
Depends on how many resources are put into it.
Yeah, that's true. That's true. Yeah. Anyway,
but if you're
yeah.
asking about if it is commercially available and everything is done commercially, one house will be printed in 1 day, 100-meter square house. We have already done the calculations for that. So basically, if it's commercial, 3D printer is available, we can print one house in 1 day.
Yeah. No, thank you so much. Myself, my research team is also available. Like you mentioned about the university linkages, and I'm sure that we can collaborate and come up with something more like a realistic, good numbers that to be translated for policy and decision makers. Yeah. Once again, thank you.
Okay, thank you so much, Abdul Sattar. Okay, so moving ahead, who is next? Who wants to ask and know about Lignik and Dr. Adeel's efforts? Who else? Okay, so Imran Saab is there.
Any more questions from the audience?
Any more questions, guys? Okay, so we have something. Okay, so Muhammad Ali is asking for your presentation can be shared in the group. Yes, we'll definitely request Adeel Saab that he allows us to share the presentation in the group among all of you. Okay, so So one last 3 to 4 seconds. If anyone is having any question, raise your hand. So
So I have a question, ma'am.
sure, sir, please.
Dr. Saab, I would like to ask one question. Do we need to use steel rebars in horizontal members of the houses? Because I have seen some videos, people are using 3D printing and vertical components of the buildings, the structural members in walls and columns. But how can we use this in horizontal members, especially the suspended members? Do we need any reinforcement or not?
Okay, this is a good question. So basically, it depends which materials are being used. So a lignic is a very strong material. It has a compressive strength of over 100 MPa. Tensile strength is like around 50 MPa or something like that. And I think residential concrete has a compressive strength of 17 MPa or 20 MPa, something like that. So this is a very strong material because it's an engineering polymer. Now, depending on which polymer is being used, it can replace steel even as load bearing and even for horizontal load bearing. Just to give you an idea, the strength and the type of materials I'm talking about, the latest Airbus A340 and the fighter jets, they are being produced using composites, which are replacing metals. So these composites are extremely strong, which are now coming into the market, and they are being produced as a replacement for metals. I hope that answers the question.
Yes, thank you. Thank you, Dr. Saab.
Thank you, Dr. Adeel Saab. Thank you so much. Okay, so as
One more question.
yes, obviously,
Ji,
sure.
Dr. Saab, I have one more question. What if we plan to shift this technology, if we are going to construct, for example, 500, 1,000 housing units in Punjab? So what would be the capital and operating capital expenditure and the OPEX, CAPEX? Do you have any data on that?
So we know that in Australia it's considerably cheaper. However, for Pakistan, that's the first step that we need to do, a techno-economic simulation, just to understand uh, how cheap or how low cost it's going to be. So based on my understanding, so this is pure on my understanding, I have not done any calculation for Pakistan. It should be considerably cheaper because there's less labor. There is the materials is basically quite uniform. We are going to use polymers. So whether we are using Lignik or any other engineering polymer. So the cost typically of these engineering polymers is $5,000 per ton. This is Australian. So basically $3,000, $3,500 per ton you are looking at. So for a 100-meter square house, you are looking at how much? 10 tons. So you are looking at approximately 40,000 US dollars for the whole thing. This is very rough calculation. I have not done. That's why I keep saying we need to do detailed techno-economic simulations. I'm off the cuff quoting some numbers. Kindly do not use them as as good. You are on mute. Sorry, you're on mute.
Okay, Dr. Saab, thank you so very much for giving such a comprehensive answers. Thank you so much. Okay, so guys, moving ahead, the next speaker we have CEO and co-founder ModulusTech. He will be discussing housing technology and showing ModulusTech system of affordable net zero housing. So let's welcome Nabeel Siddiqui Sahab. So Nabeel, welcome to the webinar.
Yes, Assalamu alaikum, Nabeel Saab. How are you?
Well, Islam, thank you. It's a pleasure being here, and thank you for organizing this very important webinar as well. So I'll share my screen. Yes.
Yeah, sure. Yes, it's visible.
Okay. All right. So I'm the CEO and co-founder of ModulusTech. It's a company that was envisioned to cater to the affordable housing challenge at large. And the way that we thought the best thing would be is to address it through technological innovation and make housing accessible for everyone that currently doesn't have housing in the world. If we look at the global perspective, there are currently 1.6 billion people that lack adequate housing today, and it's a two-pronged sort of problem where the homes that we live in are also responsible most for climate change, resulting to around 40% of global energy-related carbon emissions. So it's a difficult problem to address in that context. Similarly, in Pakistan, we've seen that there is a shortage of around 30 million housing units. And at the same time, our current housing supply lags behind by a large number. So there needs to be a scalable technology that's affordable, that's also addressing all these needs. To further make the problems worse, in Pakistan, we see that there's an increasing rate of urbanization, and most of the housing supply is catered towards high and middle income housing, while the biggest market segment, which is the low income housing, that those needs have not been addressed in Pakistan substantially. At the same time, um, we see a rising cost of construction. There's a very limited availability of mortgages. If we look at the mortgage to GDP ratio in Pakistan, it's perhaps one of the lowest in the region at the moment at 0.3%. So keeping all these factors in mind, this has resulted in our urban populations comprising of around 40% slum areas. And that is the reality that we see in major cities across Pakistan. And that is a challenge that also needs to be addressed. And to make matters worse, we see that climate change is resulting in high temperature increases, and particularly our part of the world, where in the year 2100, we're expecting daily average temperatures to cross 50 degrees Celsius. So that is something that would require a lot of air conditioning. It would require a lot of innovation in that space to keep occupants comfortable and safe in their homes. So we started off as a basic question. This was initially a research project where we asked the question, can housing be affordable and sustainable at the same time? Can we address all of these challenges? So that is something that we spent a lot of time developing. We started in 2016. We started off with a lot of research, a lot of hands-on testing, and we have now reached a scale where we have produced Pakistan's first net zero homes and affordable housing community in Karachi. So these are factory-built homes that are certified by EDGE. These are EDGE Advanced. EDGE is a green building certification from IFC and the World Bank. And this is perhaps one of the few affordable housing projects around the world which got the advanced level certification. So we do this at a cost lower than the market rate as well. So right now, the cost of a finished house ready built is around $13 per square feet, around 3,700 rupees per square foot. And the gray structure assembly time is 1 day for a single home of 3 to 5 marla. And at the same time, the lifespan is comparable with conventional construction, around 50 years. We've also made the technology very scalable. So the advantage of having a factory-built home is that you can scale much faster. So these homes are essentially built in a factory, they're packed in kits and transported to a site. They also have other features that a home typically should have. They're safe in terms of fire and earthquake. They conform with international building codes. But to compare with conventional homes, these homes are much more energy efficient, providing a lot more thermal comfort. They're also something that don't require heavy equipment to build. So that also helps reduce costs. So for example, the homes that you saw did not require any crane, and I'll share how they're built. So essentially, the base can be also built in a factory, but in this case, we did a concrete base, and the steel structure and the wall and the roofing systems are built in a factory or facility nearby. It's then transported on a truck. We can pack up to 11 rooms in a single 40-foot container. So it makes logistics very economical as well. And then local labor is trained to sort of build and assemble these homes. It's a very DIY kind of system. So no heavy equipment, no very highly technical or specialized labor is required. Once we train them to build the first home, they can build the others. And there's a low margin for error in that case. Right. We've also made the homes passively designed. We understand that low-income segments in Pakistan cannot particularly afford air conditioning, and with climate change, the climate seems to be getting much hotter and unbearable for these residents as well. So our homes, if you walk inside, you would experience a temperature difference of 10 to 20 degrees Celsius on a hot summer day. And that's because they're passively cooled, they're well ventilated, and the materials that we use are up to 12 times more insulating than a standard concrete section. So that adds a lot more in terms of insulation. We also use gradient barriers, which reflect the infrared radiation from the sun. So it's also stopping the radiation coming through the walls. So we've got an edge advanced certification, but in terms of the embodied carbon, the materials are at least 60 to 90% lower in their embodied carbon and carbon footprint of the homes if you compare with RCC construction in Pakistan. And to date, with our projects across Pakistan and other parts of the world, we've saved over 20,000 tons of embodied carbon in that manner. So the idea is simple. So we use a technology that's very scalable, it's affordable. But then to make truly net zero communities, we've now started looking at off-grid water solutions. We've also looked at renewable energy, mostly through solar grids. And we're able to build communities. So this is one example in Sindh, in a flood-prone area where the family's home was destroyed. We did a couple of projects there. We were able to give them net zero homes powered by solar and completely autonomous and self-sustaining. So in areas where they're off-grid and they're far from the cities, this option can also be achieved in an affordable manner. In Karachi, what we did, we actually partnered with a company called Trellis, which does mortgages and house building finance, to give affordable mortgages to low-income populations in the city at as low as 16,000 rupees per month. So this is a 20-year mortgage, and what we did was we bundled solar and other facilities within this construction price. So this way they were able to get a net zero home. And what we also did was we experimented with a rent to own mortgage. So families who could not afford to pay a very large down payment, which is typically 10 to 15% on such projects, they were able to first rent a home towards ownership and paying that deposit and then start their mortgages. So to date, we have a few families that have completed that deposit and they are now starting the mortgages as well. We've seen quite a bit of acceptability in Pakistan. We have done a lot of housing for employees. We've done a lot of schools, clinics, different types of projects. We've also worked in tourism, and we are also exporting these housing kits in Africa. So to sum it up, a lot of people talk about the environmental benefits of green housing, but the way we see it is that it has a huge economic impact on the country. Considering if we can make green housing more affordable, and that's where we all need to work together. And Dr.Adeel's technology is a prime example of what kind of innovations can be further achieved in the sector. This overall can result in billions in saving for Pakistan. And just to give you an idea, if we just consider that all newly built homes in Pakistan were at least 20% more efficient, we can save around $2 billion per year, and that would be equivalent of building a new Diamar Basha Dam every 10 years. So that is the sort of economic impact we can do through energy efficient and water efficient homes in the country. So that is what I feel is the need of the hour. So happy to collaborate, happy to take this discussion forward. And my email is here if anyone wants to reach out, and looking forward to the questions. Thank you.
Thank you so much, Nabeel Sir, for sharing your thoughts on ModulusTech and this brief presentation. Thank you so very much. Okay, guys, now moving towards the question regarding this presentation. Any queries from your side?
There's a question on how many stories this thing goes. So we've done typically two-story units. That is,
Yes.
1 and 2 stories are the most cost-effective. But there is an option of going higher, and we can also incorporate hybrid systems. So we can do high-rise construction as well.
Okay, request from everyone to kindly raise your hand. So there are many people, like if guys, if you don't have any question and if there is anything you didn't understand and you want to ask, you are just feel free to ask from the founder. So there is a question in the chat from Muhammad Umareli.
Nabeel,
Yes.
Nabeel,
Yeah, Quran
basically, I have a question. Yeah, I have a
Uh,
question. In Sindh, a lot of affordable housing has been constructed, being constructed through ADB and World Bank. A lot of other NGOs are donor agencies are financing the flood effects. So my question is, like they were building 2 million houses in a shortest possible time. So through this modular construction, do you think the scalability is there? If we have to build like 10,000 houses in a month time or in a 6 month time, this would be possible, or there is a limitation?
Thank you. That is a great question, and that is actually the essence of why we made these homes factory built. So we went through all these different challenges that the country can face, and this seemed to be a very scalable option. Of course, there are other technologies available out there as well, but this is something that we felt was more localized. And the materials that we use are available widely in Pakistan, and we can scale this across multiple factories, and they can produce multiple homes, and they can be assembled very rapidly. So it takes around 1 day to construct a house, the gray structure, that is. So it is very scalable in that manner, and it's designed to sort of cater to that challenge of 10 million housing shortage across the country. So thank you.
And the price $17 per square feet or 3,700 per square feet, that includes the finishes as well, or just the gray structure?
Yeah, so that is finished cost. It includes the lights, fans, and basic plumbing as well. So all of that is included. Of course, the price depends on the specifications. So that is the lowest cost of the homes that I showed in the picture. If we increase the quality and finishes of materials, it can go higher than that. But that's the starting point.
So thank you so much. So moving ahead, Asim Saab having a question. Yes, please.
Nabeel sir, how do prefab buildings compare to traditional construction in terms of its durability and the flexibility?
So the materials that we're using, they're used across the world, I would say, in our neighboring countries and Western countries. They have a very similar lifespan of our concrete and block masonry structures. Although the maintenance can be actually lower in most cases. The only difference is that there is a mindset change happening here. So normally people are used to block masonry homes built with bricks. This is a new technology, so it takes a bit of demonstration for the audience to show them how it's different and what the other advantages are. But needless to say, it's been tested. The same materials are being used for skyscrapers, for very high luxury homes across the world.
And secondly, how sustainable is prefab construction compared to conventional building methods? Since you have already got the EDGE certification for your housing solutions.
So our we don't call it prefabricated per se. We have patents, and we've sort of developed a different kind of prefabricated system. We have achieved EDGE certification, which is EDGE Advanced, which starts at 40%, although the homes are 60% more efficient, and they can actually become net zero once they're coupled with solar very easily. And yeah, the passive elements of it make the energy requirements lower as well as the homes more comfortable. So even if you're using ACs, you would require less air conditioning. There's a question on the chat on the temperature difference. So yes, in summers it can be 10 to 20 degrees lower. In winters, it doesn't work that way. It essentially the home is, imagine it's like a thermos, and if you keep something cool inside, it would stay cool longer. If you keep something hot inside, it would stay hot longer, and more efficiently. So that's how it works. And winters, it can be more comfortable and warmer, I would say.
May I ask a question?
Yes, sure. Why not?
Mr. Nabeel, excellent presentation. I just want to ask one thing, that in case there is a mass housing, there are two main actors. For example, we have some, high developers like Barrier Town, DHAs. And in the case of governments, we have the different government agencies. For example, we have the FATA, we have this PAHP, and at the federal level, we have different agencies. How you are going in case of the government agencies, if the government want to adopt this type of technology in constructing the houses, obviously it is very cost effective. But the biggest constraint for the government agencies is that they are not built in the schedule of rates we have. These technologies are not inbuilt in. What how can we add this type of technology in normal schedule of rates so as to help the government agencies to execute these type of projects?
Thank you for pointing that out. I mentioned that we had technological innovation, we worked on financial measures. A key element remains in the policy making landscape. So yes, we definitely need to look into that as well. Given that mostly for prefabricated systems, the material list is already there. The government has been actually constructing a lot of such projects, especially the military in Pakistan. They have a lot of prefabricated construction. So I think it's been very successful in that regard as well. And there has been increasing adoption in the country.
Okay, so there are a few more questions from Hassan Wakar in the chat box. Nabeel, should I read them or?
I'll just read them. So the question is, what is the perception and how it has changed, and the most significant trends shaping this sector? I would speak particularly from a Pakistan point of view. Perception has greatly increased over the past year, more like the past decade since we've been working in this sector. Initially, people thought that it would be very low quality or like labor housing sort of homes. And then once we built them and we showed them, they recognize that this is different from other prefab technologies perhaps that they've seen. So the perception has greatly improved. The best sort of perception change that we've seen is when we make people visit the projects. They can see that it looks like a normal home, and that's been our goal in terms of localizing this work as well. So the perception has greatly increased. In terms of significant trends, there have not been a lot of growth in the sector, particularly apart from I would say commercial projects. So that is something that needs to be looked into, particularly. And in terms of trends, otherwise, the green element of construction, I think, has been on the rise. So that makes a good case for such construction, the lightweight and low carbon materials.
Yeah, Nabeel, I would like to add my experience. Like we were doing affordable housing project with AMC and SAR Management Company in Faisalabad. And initially we started building building affordable housing unit with a complete block. But when we finished the house, there was strong resistance from the house owners that yes, this is not like a pakka ghar nahi hai. So there was no acceptance. So my concern will be like all over the world, the brick and mortar construction is very expensive. That's the reason people are more into modular and other type of construction which are cost effective, and also there's insulation there in heat, in extreme heat and cold weather. So we have to do a lot of awareness to make sure that people are well aware that how much benefit they are getting through these modular type of construction, and what are the disadvantages they have while even if they have a brick and pakka house. So what are the disadvantages attached to that? So we need to have a lot of awareness in order to make our case. And this is the way forward. I think in next 5, 10, 20 years, if we have to meet up the housing backlog, the modular construction is the way forward. Thank you.
Oh, absolutely. That is definitely a challenge, and I've tried to work on that a lot. So if you see this particular design, it uses a sort of red brick facade. That is to show that these homes can also be built with brick on the outside, if that is something that the end user prefers. So we did a model right next to this, which was purely prefab, and then one which was with these hybrid sort of materials. The users actually ended up preferring, and these are people from low income segments, they actually preferred the total prefab construction more. So we did a couple of these tests, but the idea has been to sort of make it look and feel like a conventional home, not like something that's different. I think a lot of test cases for prefabricated construction in the country, the homes looked very different. They looked very industrial, perhaps, and that has also made it a bit difficult for acceptance. But we particularly aim to make it look and feel like a conventional home. And we've seen some good results there. And yeah, I also mentioned that these homes are being paid for by low-income families. So that is also something that proves that there is some acceptance in that segment. Thank you for that question.
Thank you so much, Nabeel, for showcasing ModulusTech system, and your dedication to making housing more sustainable is commendable. Thank you so very much for sharing this with us, everyone.
Thank you, Nabeel sir. Thank you very much.
Thank you. It's a pleasure.
One to the next.
Okay, so now let's hear a female. Let's hear from a female voice. Our next speaker brings creativity and structure together. Let's hear from Director Communications at Partners, Ms. Marisa Batool. She is going to talk about precast monolithic construction, and let's welcome her in the webinar. Ms. Marisa Batool.
Assalamu alaikum. Good afternoon, everyone. Can you hear me? Am I audible?
Walaikum
Yes,
assalam.
ma'am.
Yes, you are audible.
All right, Ji. Thank you very much for inviting me, and I'm very thrilled to be on this platform where such amazing ideas are being discussed. Let me just share my screen so we can start off. All right, then. So we're here to solve the same problem, all of us. Ordinary families, people with constraints, financial constraints, are not able to get a solid roof on their heads fast enough, cheap enough, and sustainable enough. I would like to today introduce our solution for this problem, which is already being piloted and used in Punjab, Pakistan. Just for now, we would be discussing the current status, which has been mostly discussed by Nabeel and Adeel sir. I would be introducing the product and then applicability and obviously environmental impact and cost comparison. As we can see, we've been able to recognize that there's a housing crisis. Now we're all exploring solutions. And we're at that stage where we're being given a platform where we can adopt scalable technology, and it's getting better because the stakeholders and decision makers and solution providers are all sitting on the same platform trying to figure a way out. So just a short video of our production. we are partnering with a Chinese firm who are the construction providers in this case. And we developed the business where the partnership aims to change the construction landscape in Pakistan. So I'm sure a lot of you already know about precast construction and especially 3D concrete precast construction and its applicability, but I'd just like to go over how it helps. So it has a very high life. So it's very sustainable. It's also, it qualifies for EDGE, although we have not yet applied for it or started the process. It is 90% waste-free. It is also, the process is standardized, produced at our site. And then, as you could see in the video, that it is transported to the customer's location. It is much stronger and safer and earthquake resistant than traditional brick masonry structures. I would like to basically inform you that our structures are built in just 15 days. A 5-marla structure using our technology can be built in just 15 days, the gray structure. And since the whole process is standardized, the structure is standardized, the finishing also takes just a couple of weeks, letting the user move in a very short time compared to the brick masonry structure where there is a lot of hassle, there's lost income because of supervision needed at the site, and eventually you are not sure you're actually getting the quality that you need to get. So just going to discuss what has research proven and what do studies say about 3D monolithic concrete structures. This is a research from McKinsey in 2019, which shows that low and mid-rise apartments and also suburban affordable housing units are best served by 3D concrete structures. We do have really good use cases and examples from India, Singapore, and Philippines, where they have been able to cut the middlemen, improve quality, reduce delivery times by over 40%, and bring high quality structures, but not compromise on time or on quality. So who is affected by the lack of affordable housing or generally the housing deficit in Pakistan, as already discussed by the speakers and questions before me? There are we've realized there are 4 groups who are affected. There are the end consumers. These could be people living in rented spaces. There could be people who are living in shared areas or joint families. And there are time constrained families who are working and wait for the longest time to actually build their own house while all the time having maybe a piece of land that they could build on. Then there are business owners who want to scale up, but obviously have to rely on traditional construction methods. And then women who are in dire need of independent units or want to take up construction for their own families, but they have issues dealing with the traditional construction practices. And then architects and engineers who have to cope with labor shortages, inconsistencies, and delayed timelines. These are a lot of issues, but just some major issues that I've already mentioned. There's financial loss because of people waiting to build for years and years, the long timelines. The deliveries are much delayed, quality is inconsistent, and there's overall a very big hassle in actually building in traditional construction. This is a timeline comparing traditional construction practices, brick masonry, with precast concrete structures. So on average, what research shows is that usually people acquire land quite, early in their life, even if it's a smaller piece of land. It is the kind of investment that a Pakistani makes whenever they have the funds, but it takes them at least 10 to 15 years to actually construct on a piece of land that they already own. What are the reasons for that? We all know that, like we've already discussed, that brick masonry structures are very difficult to supervise. There are lots of issues, labor issues, cost escalations, planning, and then there has to be someone in the family, which is a general structure. A responsible person from the family has to take over the project to actually make the project work. Whereas a person who has acquired a piece of land can actually opt for a modular structure or incremental housing by using 3D modular structures, going for at least 2 modules to begin with, and then later on not be affected by cost escalations and complete their homes much earlier in life by not wasting their money on rent, and obviously the opportunity cost that they would have to pay by wasting their hours at the site while their structures are made at the factory. We would also obviously discuss the environmental impact of these 3D structures, as generally people might think that since these structures are made of rebar, steel rebars and concrete, they might be, much more environmentally dangerous, whereas they are not, because of the brick kilns that are used in Pakistan. They have high black carbon emissions, whereas the concrete components are produced under controlled factory conditions, where most of the emissions can be treated and are on their way to be treated. Cement emissions might be a little higher, but eventually the emissions from precast concrete structures are 20 to 30% lesser than traditional precast brick structures. Traditional brick structures. The wastage is a big difference between both the structures, where there's very high wastage at the traditional brick sites, but at our precast concrete structures, there is hardly any wastage, and there is efficient use of even water. There is a 50% difference in water usage in traditional brick masonry structures and precast 3D concrete structures. Material costs might seem higher when you think of this as a concrete structure and a steel rebar structure, but actually the maintenance costs are low, the opportunity costs are low, and because of this, the wear and tear is also low, maintenance costs are low, and eventually the cost of a 3D concrete structure comes out to be either the same as the brick structure, and eventually if you look over it over the lifetime of the structure, it comes out to be less than a traditional brick masonry structure. And then there are the delayed timelines and the cost escalations. If you build those in, then there's a big difference between both the costs. The types of applicabilities that we have developed. This is a way to build using our units. 3 units fit on a 3 marla plot dimension. This is what we have planned and would like to work with. Same for a 5 marla structure, you can use 5 blocks or 4 blocks, depending on the size of the dimensions of the plot, to fit in either a complete home or just 2 modules like this, which is our off-the-shelf product, to build a small 2 block home at your 5 canal or 5 marla or 3 marla plot, to give you a nice beginning to start with, and then you can, without any hassle or mess, add on more units as you go. These are the other options that you can use our units with, which are being used all over the world, especially in climates like ours, China, India, Singapore, UAE, and India. We can also build a very nice swimming pool out of our structure, which we are developing according to local standards now, and soon we'll be piloting at a couple of sites. That's about it. I would love to answer some questions if there are any. Thank you.
Thank you so much, Marisa. Your presentation was enlightening, and thank you for highlighting its potential in housing industry. So moving ahead, if you guys have any, it's a fun time. Let's have a fun time and let's take a selfie. Just guys, please open your cameras and let's take a group selfie with the wave of your hands. Okay. Just wait for a minute. Yes. Let everyone just open the cameras and just take the selfie. It's a fun time. Come on, everyone. Let's participate. So we can make as some team members are making this, but let's take. Yeah, Imran sir, we can see the bells coming from your screens. Thank you so very much. Some of you are making like hearts, which we call this. So thank you so much for the cooperation. Okay, moving back. Come on, guys, bombard this screen with your questions. Come on. Okay, raise your hand.
I can see a couple of questions. I see Nabeel's question.
Yeah.
Okay. Nabeel, do you include installation? So right now, we are working on the installation aspect, and there have been uses of installation in other regions, and will be incorporating that. But because I think that is required.
We'll definitely share the presentations once I get permission from the CEOs. Inshallah, we'll share. Okay.
Samina, Madam Sumera ne question pucha.
Okay, so there is a question from Ms. Sumera.
Cost per square feet. So the grey cost right now is 2,500 per square feet, and which can be brought down by using other materials like foam cement, and is being piloted at the moment as well. So we have a team working on finishes, but since we are relatively newer in the space, still working on the finishing aspect, it is actually easier for the customer to provide their own finishing based on, but we can provide them a complete detailed BOQ for what the finishing might need to be, and also provide finishing if it is required. But our basic structure is just a gray structure for now. Yes, Sumera, it is feasible for basement, actually very feasible for a basement. It makes basements more cost effective. So which earthquake zone? Earthquake zone, it is supposed to go to be able to resist an 8th Richter scale earthquake. And this is generally the standard used all over the world for similar structures. I will share the presentation with Durre Shahwar, and she can share it forward. Do we build in one go? So that's the whole idea. We can build block by block, and ideally this is the entire concept being used all over the world to make it modular, to make it incremental, to build as you go according to your budget rather than straining, which is a general practice in Pakistan, where we wait for years and years collecting money and trying to build a complete house and not being able to enjoy it. Whereas now, with changes in lifestyles, it is the right time to actually invest in a smaller modular structure and then opt for something, adding more later. The size of a module is, the standard size is 12 by 23 feet. The roof can go up to 12 feet as well, which can be, modified a bit. There is a bit of a margin in the sizes, which can be found on our website as well. So yes, Nabeel, the foundation ideally should also be precast. Right now, it's not, like I saw in your structures as well, and I think we all have the same challenges, and it's amazing that we can all sit together here and discuss. Ideally, yes, we should have a precast foundation. For now, and even all over the world, brick foundations are being used as well as precast. So yeah, eventually we would be investing in a concrete precast structure. So the strength of the module is 4,000 to 4,500 psi, and this has been tested by certified labs in Pakistan, and has been proven that our structures are in that range of strength. So how to fix the wall, window, and door? So since it's precast, before pouring of concrete, the steel structure has placement for the door and the windows, and then the concrete is poured accordingly. So basically, before pouring and before making the steel structure, it is very important to have the complete design, even MEP designs, because the electrical conduits are also placed while pouring. So once it is a complete plug-and-play structure, it is a complete plug-and-play structure. So once your design is finalized, all it has to do is just come to your site, get it wired up and ready to go. No openings can be, yes, absolutely. As many windows as you need, as many doors as you need, all of them can be customized. I guess that's about it, Durre Shahwar.
Yeah.
One question.
Okay. So no. How could this possible that there is one question? It's incomplete.
Yes.
Okay, Asim Saab, please.
Ma'am,
go
the
ahead.
question is from us. I would like to ask one question. You just mentioned the price of your gray structure, that its cost would be around 2,500 rupees per square foot.
Yes.
But can you give us a ballpark figure if we are going to construct a house with finishes, like with MEP and finishes? What do you think? What would be the cost of that, a finished product?
So right now, the finishing cost is going above 3,000 rupees square feet. This is what I know of the market. But I would say we can, since it's affordable housing, since it's a standardized housing unit, the cost should not be as high as that for the market, because we would be ready with the exact measures, exact details. And if we are able to finish it at the factory side, then that should bring even more efficiency and cost efficiency to the product. But
So
obviously, if you need a complete figure, we would have to work on that and then get back to you.
Yes, please, ma'am will be interested because if we are required to quote this price somewhere in any platform, so we should have the cost of a complete unit. But this is what we are
All
going to
right.
deliver to the government. Thanks, ma'am.
Okay, thank you so
Thank
much.
you, Ji. Thank you.
I think it's like the question answers are complete. So Mera's message is still there. I mean, on-site foundation. Yes, okay.
Yes, the foundation is made on site, and then the blocks are delivered and placed on top and fixed.
Okay, guys, as we have our other panelists as well, Dr.Adeel and Nabeel Saab, still there with us in this session. So if you guys have any questions from them, you may ask question from them as well.
I have a question. Like, since we are talking about modular construction, obviously, in order to avoid urban sprawl, we have been talking in other session, one of the other session arranged by Imran Saab, that we need to go vertical. So, is there any modular technology available for ground plus 4-5 story in Pakistan? If we have to, we need to start constructing those type of buildings as well. So if there is any such provision already in Pakistan, if not, how long it's going to take if one of you guys can start doing so? Thank you.
Anyone from the audience or from the speakers? Yes, please, sir.
So I'm not that much familiar about the on-ground situation in Pakistan. However, modular buildings can be constructed multi-story. And if I remember correctly, my memory serves me well, in the UK, they showed the world's tallest multi-story constructed as modular, which was like, I think, 43 stories. So this technology is quite well advanced in terms of constructing multi-stories. It depends on the materials and depends on what sort of modules are being constructed. So if it can be done in one country, it can be replicated. However, when we are talking about 3-4 stories, multitude of or a variety of materials are available for modular construction. But modular means it's modular. So we have to look into the other aspects of modularity when we talk about modular. So it's so modular is one type of prefab. So I'm only focusing on modular at the moment. I hope that answers the question.
Thank you. And anything from the Nabeel side? We want to hear.
Add a bit on that. So we have developed prototypes for 3-story buildings, and they seem to be very feasible. If we go anything above that, then the cost per square foot increases generally. It could be done using a steel structure, or it could also be a RCC frame. So the columns, beams, and slab can be RCC, and the walls can still be modular. So you can have hybrid sort of arrangements as well. So, but the only issue is that the cost per square foot generally goes up when you increase the stories beyond 3 stories. So generally for affordable housing, because the land is supposed to be less expensive, it's perhaps more horizontal, and 3 to 4 stories actually works best, in my opinion.
Thank you so much, Nabeel, for adding on. And thank you so much, Marisa, for answering all the questions, and Dr. Adeel Saab for participating and extending through the questions. Okay, so as we are on like around 4:30, I would like to give floor to the Imran Saab, Program Director, Punjab Affordable Housing. Please, sir, we want to hear from you.
So thank you very much. First of all, that we saw that participants number growing almost 45 touching 50. it shows the appetite that the way we are actually trying to push the agenda for affordable housing and trying to bring an ecosystem. So I'll be extremely thankful for all the participants that they took the time and actually helping us and encouraging us that we need to continue to come up with these kind of sessions. So thank you very much, everyone. I think everybody need to clap for themselves while staying with us. And then big thanks goes to Marisa, Nabeel, and Adeel Saab that our session would not have been so successful if you not partnering with us. People like you who are, for each session, they actually volunteer and you guys are sharing your incredible researches with us. I think my life may have been made much easier to conclude with reference to question that was actually done by Rizwan Saab. And I'm sorry that if you can just hear some background noise, because we wanted to just feel that how the housing construction goes. So it's better that before you start housing constructions for others, you actually start living in where that housing is being constructed. So if hammering sound is coming, I'm really sorry because we are mid of at one ongoing site. That is our own office. But again, coming back to the Rizwan Saab comment that with our all the issues of MRS rates and the traditional way of how the government does the business and how we can encourage and make all these technologies from ModulusTech to the K partners, modular technology, or Lignik of Dr.Adeel, and so many other which are right now increasingly available. So how the government who is love to work in inertia and silos and whichever the thing which they make it part of the policy rules regulation, sometimes it takes ages and centuries to transform them. So how we are going to actually move the thing towards this forward looking. So again, that why these kind of sessions are being planned, why even the existence of Punjab Affordable Housing Program came into being, shows the appetite of government of Punjab, where we want to break the chains and come up and explore these kind of technologies, encouraging them and make part of our upcoming program. That's why Ms. Marisa, Adeel Saab, Nabeel Saab, it will be our request that you continue to guide us so that we are really looking forward for these kind of things. And I saw a number of comments and other question answer session also that there are so many other potential researchers, academicians, and developers who are really trying to lead us. So please, this, a forum is yours and we need to actually collectively push the thing. And with thanks, I'll be ending that one Iqbal, that verse is actually resounding back of my mind when he says that आइन नो से डरना तर्ज कोहन पे उड़ना मंजिल यही है कठन कौमों की जिंदगी में. So again, that the way we had been constructing the housing for past 200 years, it's time that we actually welcome these kind of 3 technologies which actually introduced today, and we'll be really looking forward at how we can make the people's life easy. That's all from my side. Over to Durre and Asim Saab.
Thank you so much, sir, for joining us and for the conclusion remarks. Okay, so as we are continuing with the session, I would like to hand over the floor to Asim Saab for sharing his insights as we are at the ending minutes of this session. And please share if you guys want to share anything from your side about this session, any remarks or anything. If you guys, because this is the open floor for everyone, because we are done with the presentation and our speakers are there. So over to Asim Saab.
Yes, thank you all for joining us today for this insightful webinar on prefab buildings and 3D printing techniques. These are, although these techniques are not new in the international market, but unfortunately in Pakistan, we are too late in these technologies and in the introduction of these technologies. In Pakistan, we have been constructing pre-engineered buildings since 1995, I think, and prefabricated concrete structures are in the development and construction phase since 1965, as far as I know. So it is the right time to jump from the traditional conventional construction with brick masonry and concrete structures to an alternative housing solution that we have today discussed in detail by our experts, which they have suggested us. So based on this discussion, what we have heard from our experts, that 3D printing is a good solution, but we are still concerned about its capital cost if we install the plant in Pakistan. We'll request Dr. Adeel to give us more information on this so that we should collaborate with them. And if we want to transfer this technology to Pakistan, if some developers are interested to make a start with this technology. So how expensive and how sustainable this technology would be in Pakistan or in our industry. Based on other two discussions that we have heard from Ms. Marisa and Mr. Nabeel, constructing a prefab building up to 3 to 4 stories would be a very economical solution as far as this affordable low-cost housing is concerned. So if we go vertical and more higher stories, it will obviously become more expensive. And if we stay close to ground for a horizontal construction, single-story building, again, this will not be an economical solution. So going up to 2 to 3 story buildings with these innovative materials and these techniques will be, I think, a best solution for our future and for this program. So this is all from me. This is what I've observed from our today's webinar. So over to Ms. Durre Shahwar, please, ma'am.
Thank you all the speakers for your just launched our YouTube channel, which its name is Urban Park, and every webinar's recording is available right after 2 or 3 days on this YouTube channel. And I'm going to share social media links and the YouTube channel link in the chat box. So much, everyone, all the speaker, Dr. Adeel Sahab, Nabeel Sahab, and Ms. Marisa Batool for taking out your precious time and participate in this webinar and sharing your insightful discussion and everything. Thank you so very much.